Astronauts to the moon.
Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
What's going on, everyone? It is Jaron from Jeranism, back with another live video for you this afternoon. Thank you guys so much for joining me. I do appreciate it greatly, as always. Today we're going to be... Oh, and I see Bob in the chat giving me a hard time about being late. Way to go, Bob. Thanks a lot. No, I'm just kidding. No, I'm going to blame my guest tonight and myself. We're both equally responsible a little bit. But
that's true.
Today we're going to be listening to a presentation. Basically, I've done this before. If you've listened to my channel, you've seen me do it with Travis from Life is Short. You've seen me do it with Ranty Flat Earth, with Nathan Oakley. You've seen me do a few of them with Iru Landucci, and we've got more of those coming. He's got an Electric Universe presentation he wants to give, some other NASA stuff that'll be upcoming, so stay tuned on my channel for that kind of stuff. I also did one with Clint Wayland on history, and we've also got some more of those coming up as well. I've been talking to Clint lately, and he's got some more stuff for us. So basically, if you've ever listened to my channel, you know how it is with me. I like to hear both sides of the story. I like to get different people's take on it, and then we kind of can all decide for ourselves. So sometimes this issue may be considered contentious. I don't think it needs to be. I think we can hear different people's ideas and their opinions of it, and then we can make our own informed choices based on the presentation. So you won't hear from me a whole bunch throughout this because it is a presentation, and we can get to sit back and kind of observe and listen and see which one we agree with. So before I introduce my guest, I just want to real quick go through one little quote, and it's also in his presentation, but I think it's important to point out. This is from Isaac Newton in a letter to Bentley. He said, "It is inconceivable that inanimate brute matter should, without the mediation of something else, which is not material, operate upon and affect other matter without mutual contact, as it must do if gravitation in the sense of Epicurus be essential and inherent in it. And this is one reason why I desired you would not ascribe innate gravity to me, that gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum, without the mediation of anything else, by and through which their action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. Gravity must be caused by an agent acting constantly according to certain laws, but whether this agent be material or immaterial, I have left to the consideration of my readers." So to me, and again, if you've heard my channel, if you've listened to me, you'll pretty much understand my opinion of it, which is that I think the so-called force of gravity is only required in order to have us believe that we can stick to an imaginary sphere flying around in the vacuum of space. I don't even believe that force equals mass times acceleration. I believe that that is an equation. It is man-made to help explain things, and it doesn't mean that it's true. And so today we're going to listen to a presentation, and my guest is Sleeping Warrior, otherwise known as Anthony Riley. Tony, are you there?
Yeah, man. Can you hear me?
Can hear you great. So let me set up your screen here. There we go. And so you're all set. So whenever you want to begin, let's get started. Or you can just tell people why you've chosen this topic to talk about. And one thing I wanted to point out to people too is if this is something I'm open to doing, if anybody out there, if you're a flat earther, if you've got maybe you're a baller skeptic, but you've got some sort of presentation that you want to give. Maybe you've got a small channel where you've only got 1,000 subs or something, and you want to get that presentation out, kind of like what happened with Travis from Life is Short or Ranty or any of these other people. If you've got something and you want to email me at Jeranism at yahoo.com and just put presentation in the subject line, I'll be looking out for those. And basically you can do the same thing Travis did, which was kind of sent me his presentation, or the same thing that Anthony did. Give me a chance to just look at it and say, yeah, this is something I think should be presented. I think people should hear it out. I think that's a great reason to use my channel for, and it kind of helps us all out. Lets me listen to your presentation, lets other people see it, and we can go from there. So yeah, just tell us why you chose this topic. Anthony, go ahead.
In a nutshell, it's probably the most contentious on both sides. It's one of the most fundamental things that we all consider right at the start when we start our own journey. And you've got to make some decisions along the way. You've got to decide, do you think it's there or not? If it is there, can they prove it? If it's not there, what's the crack? For me personally, my position on this is that there is no such force. There is no such thing as gravity the way that we're told. I'm open to the idea that there could be some extra, some like electromagnetic effect, perhaps ethereal. The spitball inside of it, I'm fine with. But for the purposes of this demonstration today, I'm going from the perspective that what they're telling us is gravity is complete and utter bunkum. And we can explain it away with current science that isn't what they're telling us it is. And I'm going to assert that we've all been brainwashed by this concept called gravity, so that there's no consideration at all for anything else. And there should be, because we can demonstrate that there is something else. And there may be an extra force of some kind, but I'm not going to touch the spitball side to it. I'm just going to talk about what they tell us and basically show how it's not the way we're told. So
awesome.
Let's move straight.
Yeah, let me just ask you a question real quick. So would you say that relative density explains it all for the most part?
Yeah.
Okay.
Yeah.
And currently that's my camp too. I mean, a lot of people want to say, well, why do things go down? I've heard that from a lot of people I've tried to talk to about this issue. And again, when you're talking about relative density, as soon as there's a change in that equilibrium, a difference in the equilibrium, something has to go somewhere. And so if it went sideways, well, then our feet would be attached to the side, and we would call that down. So I don't get caught up on this whole idea of, well, why do things go down? Why is there a preferred direction? Well, there has to be a preferred direction if there's a change in the equilibrium. So I'm a believer in relative density, but I want to hear this presentation and see what I think after that. So like I said, go ahead. I actually, before the word force to me is just hilarious, because whenever I hear force, I don't know why, maybe it's just me, but I think Star Trek and Star Wars and this magical idea of force. So force to me is hilarious. And I know a lot of people, and Bob's one of them, that talks to me about acceleration, that there has to be a force if there's an acceleration, and I don't even believe that really the acceleration is caused by that necessary force. So I described it the other day, I think, on the Ranty-a-thon. People should check out Ranty Flatter's channel if you didn't get a chance to watch that. I joined them for about 3 hours there, and we tried to raise some funds for Ranty to get a drone. But one of the things I mentioned there is if we placed a car in neutral on a slightly downhill and that car started to roll down, I believe that it gains momentum. And I think that it's the same thing as when you drop a ball out of the air, that it's going to go faster as it travels down because it's gaining the momentum of the speed that it was going before the speed it's going now. And so that's why I want to hear this presentation. So I'll step out of the way now. Anthony, you go ahead and begin when you're ready.
Right, well, I'll start with a shameless plug. Me and Ranty have got this little fight that we're having, where it's not right that Ranty's got a similar amount of subs than what I've got. I've been here longer. So everybody go and sub to my channel, because I need the subs. I'm not monetized. There's no adverts, generally speaking. So there's my cheap plug. I recently did my own little experiment. It's on my channel. It's a couple of videos old, and you've got it on screen. Literally, egg, water, salt solution, and literally you can see by the bottom left-hand picture where the egg started, And by the bottom right-hand picture, which we'll come to in a bit, it's not in this picture now. It's in. You'll see the results, and make the egg move with a little bit of salt. And this is essentially, in a nutshell, what I'm going to talk about. Now, what I need to do is move this out of the way. That. So you've got to start with the first fundamental question of, well, what is gravity? And it's one of those things where there is no real right or wrong answer on our side of the fence, because once you realize that we're not spinning and we're not orbiting anything, there's no curvature. Gravity is one of those things that becomes moot from our point of view, because it may be there, but it may not be there, and we don't need it. And we don't have to explain it by keeping the atmosphere on. We don't need a force to hold our atmosphere in. We're contained by something. I don't know what, but we're definitely contained by something, because we do have gas pressure. But they definitely need it. It's absolutely essential for them to have something to hold the atmosphere onto the ball. But for us, it's discretionary. We don't necessarily need it. It might be there, might not be. For us, it's moot. But what is gravity? Try looking yourself and finding a consistent, reliable definition for what gravity is. It's really hard. It seems to be deliberately obfuscated. But back in the day, prior to 1915, Newtonian principles, it was a force. And ballers cite this all the time. They cite Cavendish experiment as their demonstration of force. And it's nonsense, because it was superseded in 1915 with Einstein's general relativity theory. And he said that it was no longer a force. It was obviously the curvature or the bending of space-time. Problem is, it's mathematical by nature, and we can't do any testing or experiment with it. But by 1915, that's where his paper came from. By 1920, 5 years later, it was generally considered to be true, whatever this thing is, this curvature of space-time. But we can't test it. It's purely mathematical. So whether it was a force or not, by 1915 and 1920, it's now gone out the window. This concept is gone. So move down the next slide. We have to start with a definition. There are many definitions for force, and you can cherry pick which one that you want. You can pick and choose. Some of them say more loose things, some are more specific. But keeping it simple, it's basically an interaction. It's strength or energy as an attribute of physical action or movement. For me, there's got to be like a physicality to it. There's got to be something that you can point to and say, that's causing it. So if I push you by the shoulder, it's me that's pushed you and you've moved. But if I don't push you and then you suddenly move, I'm going to wonder what's going on. But I didn't cause that. There was no force. Something else has happened, and it might have been a convulsion on your side. But for me, the word force, there's got to be an interaction of some kind. There's got to be something that's causing it. You can't just have this spooky action at a distance the way we're told, because it's just nonsense. And I'll come to the reasons for why it's nonsense in a sec. But there has to be a physical action for me. And I mean, it's moot. You can talk about what definitions mean in this context all day. I don't want to dwell too much on it. But ballers demand that we apply a force when we're talking about this stuff, because they need their Cavendish experiment to be something that they can cling to at all times. But it was superseded by 1920. So even though they talk about Cavendish all the time, it's gone. Nobody ascribes to it anymore according to the current science. So it's antiquated, but they insist on having it. And really, we should just say no, because it's not the current science. The current science is a mathematical concept applying principles of bendy space-time, whatever that actually means. Now, even if they were to have force, according to Cavendish, it was 1 in 50 millionth. Let me look up what the top line says. The force with which these balls are attracted by these weights is excessively minute. It's not more than a 50 millionth of the weight. So a 50 millionth is not a lot. If you broke down in your car and somebody, a good member of the public, stopped and said, yeah, I'll give you the push, but I'm only going to push a 50 millionth of your car's weight for you, you might as well not bother. It's not going to do anything. So even if they could have this weight thing, it's a 50 millionth of the object's weight. That's the context that we're talking about. Now, Jeran's just read that paragraph this letters to Newton. I'm going to read this part again, because it's so prominent that Newton said basically, you're not ascribing this gravitational thing to me. And I'll just read it from the highlighted bit. And this one reason why I desired you would not ascribe innate gravity to me, that gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum without the mediation of anything else, by and through which their action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into. So if you're going to argue for Cavendish and you want Cavendish in, the problem you've got is even Newton himself said, don't ascribe this to me. This is not, I don't want this. So, and obviously he was giving it like posthumously or whatever the word is after he died. It's nonsense, but it's antiquated science, so we don't need it. So let's not talk about too much about forces. Let's talk about what we can demonstrate. Now, I've got on screen, I'm gonna pick on Bob a little bit here because me and Bob don't agree on this topic, and that's fine. Bob's message in chat before was the so-called gravitational force only goes in one direction, down, which is not a relative direction. Well, given that the current science, according to Einstein, for gravity is like curvature of space-time, Einstein, according to Scientific American, quantified or identified what down actually means. And according to Einstein, down is defined by the direction in which time passes more slowly. It's not the direction in which heavy items fall or helium balloons don't fall, they go up to or whatever. Down is defined as the direction in which time passes more slowly. What on earth does that mean in the context of gravity? It means literally nothing. It's obviously to do with time dilation, but it means nothing from our perspective because it's just gobbledygook. It's like there is no down, is my position. And I'm going to come to, I'll explain for why there is no down in the next few slides. But Einstein said down is time dilation. It's not a direction of like falling. So just bear that in mind. Because Einstein's conceptual mathematics for this bendy spacetime, because Einstein's maths is theoretical physics, it has no application in science, in the world of science, because the problem is it's theoretical by nature. It doesn't have any experimental tests. You can't do anything with it. So it's pointless. It's literally stories. Now, I'm all right with stories if you're under the concept that they are stories. I'm all right with Santa. I understand that there's a time and a place for Santa, and it's usually up to about the age of 6. But a lot of people don't realize that if it's just theory, theoretical physics is pointless. Really is pointless. So that's the context for where Einstein kind of stops. So now we're left with Newton's replaced by Einstein. Einstein's pointless because it's theoretical. But within the community on our side, there is that moot point, which is, well, is the summit that we can talk about? Because there does seem to be a down. There does seem to be something holding us onto Earth. I've heard people on our side say, I can feel gravity. Well, if you can feel the force of gravity, remember, if it is a force, it was only a 50 millionth of your own weight. And I'm going to say that nobody can feel that. So let's move on. We've all seen this density tower. And the thing with the density tower is when you have these labels, all these labels don't really mean anything to you other than they identify what the liquids are or what the solids are. But let's not think about them in terms of names. Let's think about them in terms of values. So we've got, what I've done is I've removed all the numbers and I've just put random numerical values. And look at the scale. The scale is less dense at the top and more dense at the bottom. I haven't used the word buoyant at the top. I've used less dense. Now, the thing is, with this now, we can see that because we know what we're looking at in terms of these liquids, if I was to give you an unknown substance that may be liquid or it may be solid, and I just told you what value it had, you would know where it would sit in that density tower. So if I came out with, say, substance X, and I said it had a value of 13.2, it's going to blend in with this other one at 13.2. So it's going to sit there and it's going to coagulate or whatever. Something weird will happen at 13.2 because that's the number I've just told you. But if it was 17, you know that it would sit between 13.2 and 18.1. It's so intuitive. It's so simple. If it had a value of 56, you know that it's going to be towards the bottom. It's going to be more dense than the thing that's in here. If it had a value of 10, you can see where it's going to go. It's so easy when you see that these things are all numerical, right? But remember that we're in the medium of air. This whole density tower in this container, it's in the medium of air, and air can be 1. So if you've got the relative, because we're all in air, because we're in that medium, and if we give it a value of 1 because we're all in it, then if you know what the density of the thing is that you're playing with, helium balloons might be 0.2, so you know it's going to rise. Hydrogen might be 0.16. You can tell what's going to happen if you know the medium that you're in. Think about a swimming pool. I weigh 16, 17 stone, whatever weight that is in pounds. When I stand at the side of the swimming pool, I can exert a so-called force on the scales, and I can tell you how heavy I am. Chuck them scales in the deep end of a swimming pool, and you can't even put a weight on them. So the only thing that's changed is the medium that you're in, because you can't put weight on the scales when you're in the medium of water, because you spring back up again straight away. So if you think about the way that our realm where we live, and give the air that we're in, instead of not giving it a value, give it the value of 1. Because then helium, hydrogen, and all the lighter gases can be less than 1, and everything else that you're picking up, however heavy it feels, can be a value greater than 1. And then you can rank them according to how heavy they feel. And if you know the density of them, then that's going to tell you what's going to happen, always. And we can measure density as well. So that's really how I'm seeing what's going on in terms of relative density. I'm seeing that we're in the medium that's 1, and everything that's around us is either greater than 1 or less than 1. If it's less than 1, it rises. If it's greater than 1, it doesn't rise, it goes down. Now, remember, down is the direction in which time travels more slow, according to Einstein. But really, it's just going down towards its state of more density. Now, I'll pick on this little cherry tomato in the middle. I think we can all agree that if I was to pull the cherry tomato up and then let go of it, it would resort back to its position, and it would go back into its position it's currently in. But the same would happen if I pulled it down. If I pulled it down and pulled it out of its equilibrium, it would rise back to its position where it's comfortable. Why it does that, I don't know. It's the same argument for why does hot go to cold? Why does pressure go to non-pressure? I don't know why it does it. It's just the way it's been made. It's just, for me, it's just a law of nature, because that is what it does. I can't really explain it. I don't understand it, but that is what it does.
Right. So
I could probably work out some maths for it. But
what you're saying right there, just real quick, what you're saying there is when people say that there's a preferred direction down, then it's the same thing as saying there's a preferred temperature, which is cold. Right?
Yeah.
Okay. Keep going.
And there's a preferred pressure, which is not pressure.
Right.
So the other thing is when people say things like density and why don't things go sideways? If I was to pour a liquid into anywhere in this container and it was to find its state of equilibrium, it would fill sideways before it got to the restriction of the container itself, and then it would be forced to move up and down. So we do see things go sideways. We see smoke rise in the atmosphere and it'll level itself off, and then it'll seem to sit horizontal in the atmosphere. You can watch it from a distance. If there's a car on fire or whatever, you can see the black smoke billowing up in a column, but then it levels itself off and then goes across. So we do see things moving sideways. So that's not always true to say that it doesn't, because we do. So moving on, this is where it gets a little bit crazy. This video from the Action Lab is probably the best video that I've come across. And what this video does is, you can find it by typing in helium balloon in a vacuum chamber. What it does is he gets 2 little water balloons and he fills them up with helium. And then I just realized I'm getting some feedback. Hang on. That should be better. So he fills these balloons up with helium and he puts them in his little vacuum chamber. And before he removes any of the vacuum out of the chamber, the balloons float. Now, whatever value these balloons have, there's air in that chamber at the moment. So if we give the air in the chamber 1, and we know that these balloons are floating, we'll give these balloons a value of anything less than 1. So we'll say 0.6 or 0.2 or whatever. But don't forget the balloon itself has got a little bit of mass to it. So if we say that the helium's 0.2, for example, and then the balloon itself has got a bit of mass to it, that can bring it down to say 0.6. So it's closer to 1. He starts to evacuate the chamber, and the balloons start to get bigger. Now, obviously, this is one of our big points. How do you have gas pressure without a container? Well, obviously, the Earth in space, it needs containing. But that's tangent point. The balloons start to expand as he starts to remove the air inside the vacuum chamber. So as he starts to remove it, the quantity of air gets less and less. So the density of the air is also getting less. It's getting more sparse. So the 1 starts to become 0.99, 0.98, 0.97, 0.96, and eventually it gets to the point where the balloons get that big. The medium that the balloons are in can't sustain it anymore because it's being changed, relatively speaking, because the air's being removed. It gets to a point where both of these balloons now are pretty big compared to what they were at the start. And if you notice that they're both sat with the bit like a ballerina, they're both sat just tippy toes of the balloon, and they're both sat right on the very tip of what they're on. They're vertical, but they're not laying on the floor. They don't look heavy. They look as though they're just touching. But then what happens is one of the balloons bursts accidentally. Let's go to the next one. Now, this is where it gets interesting, because when the balloon bursts, the helium that was in the balloon has filled the available volume. We know that's what will happen. But the question is, we don't know whether it's a pure vacuum in there or not. So it's either going to fill the available volume, or it's going to pool at the bottom, or it may pool at the top. It all depends on how much air is still left in there. But look at the other balloon now. It's not like a ballerina on the tippy toes. The other balloon's now on its side, and it looks more heavy. So something's happened with the helium that was in there. Regardless of what it's actually done, it's either pooled at the bottom, pooled at the top, or it's filled the available volume. But whatever's happened, the balloon now has gained weight relative to what it did look like before. Because what it did look like before, when it was there, it was just touching it with its tippy toes. But the other balloon bursts. Now it doesn't look as light anymore. It looks a bit more chunky on its feet, and it's now on its side. Something's changed inside that chamber to give that balloon now apparently more weight. It feels more heavy. You can see it's not erect anymore. It's laying on its side, and it looks heavier. This for me was a query early on, and I couldn't work out what was going on because you can't see the gas. But whatever you think's going on here, it's moot. But whatever you think's going on, it could be that it's pooled at the bottom because the medium it's in can't sustain itself anymore. It could have gone to the top because it can, or it could have filled the available volume. We're not quite sure. But the point is, the other balloon seems to have gained weight relative to what it was like before the other balloon burst. So just have a think about that, how that works or how it doesn't work, because it is important, because it helps you conceptualize what is going on here. So let me just talk about this, my experiment I did the other day. So what I did, let's make that bigger. So what I did here, I'm just playing this slow. I'm just waiting for this banner to leave. Not going to do it, is it? Okay. So on the left-hand side of the image, I've got my egg, and I've got clear tap water. I've got the salt solution which I've prepared the day before, and I've got my egg just so it's just off the floor. And then what I do is I pour my salt in. Now the egg hasn't changed its density, but I am going to change the solution that the egg's in. I'm going to add density to it. So what should happen is the egg should rise, and if it rises, then basically the more salt I put in, the more it'll rise. If I just put a little bit of salt in, it'll only rise a little bit. But it's that control that proves that relative density is a thing, because it's not gravity that's doing it. I'm not changing anything here other than the medium that the egg sits in. It's just like the helium balloons. So when I pour the salt in, now there's not a lot of salt going in there now. And granted, it doesn't immediately dissolve, but you can see that that egg has moved. Now, if we remember Newton's first law of motion, F equals ma, any object at rest will remain at rest unless acted upon by a force. Well, that egg's just moved. So something's happened. Now, that people like on the ball Earth side, I'm not going to name names, but people on the ball Earth side say things like, density's not a force, weight's a force. And I've never challenged it because I didn't know that there was a challenge to be made. But I measured the density of the tap water and it came in at 212 parts per million. I measured the density, and I say density, I used a parts per million counter. Technically speaking, I should have used something else, but the other thing that they wanted us to use was based on gravity. It's calibrated using gravity, but I'm happy with these parts per million counters because it is showing how much particulates are in the liquid. The salt water had 299 parts in it. And when I put in the extra bit of salt, it went up by 10 parts per million. It's not that much, but it was enough to make the egg move. So what if you can see the bars in the way here, so it's a bit awkward to see it, but the egg's now in a physically different position to what it was in before. And I've done that by putting in the egg, by putting in the salt, and the salt was the interaction with the density itself. So for me, there was a force, but we're told that density is not a force. Well, how's this explained? Because if you've got the mass of the Earth underneath the egg, underneath the table, and then I've put in a bit of salt and I've increased the mass below the egg, shouldn't the egg be attracted towards the bigger mass? Because I've changed the mass. That's what their narrative says. They say a buoyant force has sent the egg back up the other way. I say, well, that's an additional force that's not part of the test. Where we've got scientific method, you can't infer extra causes unless you can demonstrate them. There's only one independent variable and one dependent variable in a scientific experiment. Now, if there is more than one or two, if there is more than one, so you got 2, 3, or 4, or whatever, you get to something called a complex hypothesis, and it gives you a correlation afterwards. It doesn't give you a cause; it gives you a correlation, and a correlation is not cause. We all know that correlation is not cause. So if there is, they need to demonstrate it and show what the effect of it is, and we know that they can't. So I'm going to say that the only thing that was changed was the medium. And I'm going to say also that you can't infer extra causes because you can't demonstrate it. If you can't demonstrate it, it's not there. It's just a story. Just like you can't demonstrate Santa. But we all believed Santa for a while, and children believe Santa all over the world. But it's still just a story, right? And we all know it's not true. It's the same for this. Why is it that we're getting these inferred causes rammed down our throats? We shouldn't be. It's their claim to prove. So let me get out of this. So it got to a point where I thought, well, what is there out there that can demonstrate what we're looking at? Because there definitely is something going on here. So someone reminded me today, shout out to Dr. John D. He said, remember the Cartesian divers? Now, the Cartesian divers, basically, it's a little pocket of air, and you can make them float. But where they come in useful is when you put them in a completely sealed container, and then you apply pressure. And what happens is the little pocket of air that's inside these little Cartesian divers fills up with water instead because the air compresses because you're putting pressure onto it. So what you're doing is the interaction would be the pressure that you're creating by squeezing it. And it forces water into the area because it squashes the gas that's in there because the gas is compressed. You can squash the gas, but you can't squash the liquid. And as we do this, obviously, you squeeze it and the thing goes down. And ballers would have you believe that was gravity. But they would also then tell you that it's a buoyant force going back up the other way because that's the opposite of gravity. But we're controlling it. We're changing the relative density of this little man because we're squeezing it, putting a pressure into it, and it's filling up the thing with water. It's not a lot, but it's enough for it to be able to move. So we're controlling that. It's not gravity. It's not buoyancy. It's changing the density of the little Cartesian man. And all you got to do is squeeze. So here's another one. Again, you just got to give it a bit of a squeeze, and it'll drop. And then when you let go of it, it goes back up. But there's no gravity and buoyancy there. It's literally we're creating the pressure that's changing the density of the thing. Remember, F equals ma. If there's an accelerating mass or a moving mass, then that means that there is a force there according to Newton's first law. Whether we accept that or not, that's what the science tells us. So it does seem to be the case that relative density is a thing. Now, check this out. This is the final one I want to bring up. This lady here, this is quite an old clip, but this lady, she's getting, she does two little experiments here. She's got a nearly inflated helium balloon that she heats up with a heat gun, and she increases the volume of the balloon. That causes the balloon to rise. When the balloon cools back down again, basically it shrinks again because it cools down, and then it causes the balloon to not rise, drop. But the volume's changed on the balloon. The mass didn't change. So gravity is supposed to be dependent on mass. However, the mass was constant in this. So gravity has to be constant if it's there at all. Or it is there, but it's not the cause. Something else is the cause. And it's to do with her putting heat into it, changing the volume, and then the balloon rises and falls. So if gravity is there, it was a control. I'm going to assert that it wasn't there at all, and it isn't a control. There's just no gravity. So that was the first one she does. And she does another one, which is basically another sealed lid and another sealed bottle, a little teat pipette, which is like that little diver that we just seen, and a tomato sauce sachet. Same thing. She squeezes the bottle and they'll drop. Let go of the bottle and they'll rise again. Now, the reason why this is important is because she gives the explanations now for why these things did what they did. So I want you to listen carefully to what she says, because when she explains these, it's not what she says, it's what she doesn't say. She doesn't use the word buoyancy. She doesn't use the word weight. She uses the word mass, and she uses the word less dense. So listen to the phraseology that she uses, because it's really important, particularly for what she doesn't say. So I'm hoping that we'll get this sound now. Jeremy, you'll have to tell me if this comes through. It should do.
No.
Ketchup packet is less volume, but the same mass, and that's why it's sinking. That's a tough one for them. They have to...
Did you get all that then, Jaren?
Towards the middle it started, so you're fine. Just do it again. Rewind it a little bit.
Yeah, I'll do it again. So listen carefully to what she says.
The ketchup packet is mass. That's why is more mass. Eyedropper.
Here we go.
Okay.
The eyedropper is more mass. That's
The eyedropper is more mass.
why it's sinking.
That's why it's sinking. The eyedropper is more mass. That's why it's sinking. Not gravity, more mass. So if mass is the thing, then we've got to have density here, right? That's why it's sinking, she says.
The ketchup packet is less volume, but the same mass.
The ketchup packet is less volume, but the same mass. Notice what she's not saying there. She's not talking about down. She's not talking about gravity. She's talking about density, weight, not weight, mass. So it's really easy to fall into the trap of weight, but they've hijacked weight with gravity, and that's why it's really easy to trip into it. The other bit is this.
And that's why it's sinking.
Now, what I want you to do now is this little clip now. It's only a couple of sentences. Apply this to people that believe in gravity, because this woman basically talks to the children, but it transfers directly over to the ballers. So listen to what she says now and apply it to the ballers.
That's a tough one for them. They have to remember density, and no matter how well you drill density into their heads, they still have a problem with that.
They have to remember density. No matter how much you drill density into their heads, they've still got a problem with that. So it's almost as if she's telling us that you were told this when you were younger, but you've forgotten it, and people struggle to remember it. Well, there's a good reason for that, and that's because we've all been brainwashed that gravity is the cause of everything. Well, whether gravity is a force by Newton or a bit of bending of space-time by Einstein, down is, according to the current science, it's the direction in which time travels like more slowly. So whatever down means, according to Einsteinian principles, not up and down. It's more dense over less dense, and that woman's literally just said it. So overall, it depends on what your viewpoint is. It's moot inside FE. We don't need gravity. It may or it may not be there, and it's an interesting point. But if we can all accept that we're not living on a sphere, they absolutely need gravity to explain how they can hold the atmosphere onto Earth, which we'd all accept. We know that that's nonsense anyway, but we don't need it. So we don't need to worry about it. It's just interesting to have the conversation. And I think that's the end of this one now. Yeah, so I'm done with that. I think that might be the end of it. Yeah, that is the end now. So what I'm going to do is turn off screen share because I'm getting a little bit of feedback. It's driving me mad.
Okay.
Stop sharing. Right, that'll stop now. So basically, regardless of what people's views are for gravity, it's worthwhile having a conversation about it. Relative density, remember that we're in the medium of air. We're not in a vacuum of zero. That little bias, that little greater than zero value that we have, the air that we are in, that's where the perception for up and down's coming from, because we're not at a value of zero. Because some things do go up. But remember, up and down are relative. They're concepts that we give them names. It's like how fast or slow does your car go? 60 mile an hour. We know what that means. But it's still a rate of speed. But we give it a value. Up and down, we give it that value. There was no human there, and you told a fish to swim down. The fish is going to be like, what do you mean down? I don't understand what down means. I need pressure, or I need cold, or whatever it is that fish use to calibrate their direction. So it's not up and down for me. It's relative to the medium that we are in, and we're all in the same medium. So, Jaren, come on, talk to me. Where are we at?
As far as I go, and I've been there for a while, is relative density seems to explain it all quite well. I mean, of course I could be wrong, but the only argument I ever hear is, why do things go down though? And then you might as well ask me, why do things go from hot to cold? Why does high pressure go to low pressure? Well, it just does. It just is. So just as Anthony showed that density tower, all of those items have to seek their own equilibrium, meaning that they are in disequilibrium and need to arrange themselves correctly. So some of the items actually go up, other items would go down, and depending on what their individual densities are, that's what decides which direction they go. So I feel like my weight is simply my relative density. I'm far more dense than air, far more dense than air. How much more dense? Significantly. And so is basically everything else that we see. So to us as humans, I think it draws to the question over and over again as to why do things go down. Well, the reason things go down is because almost everything is significantly more dense than the medium which they reside in, until you get to water. Then water, you have a lot of different things going on. You start, having a different direction. I've heard people say, well, why don't things go sideways? And again, if they did go sideways, well, then so would our feet. We would be standing sideways, and then we would call that down. So I can't, get behind the idea of force equals mass times acceleration. Even if we take a look at items accelerating and say, well, why do things accelerate going down? They have this 9.8 meter per second squared speed that they build as they go down. And again, I mean, I'm able to explain that with relative density, because if you dropped a golf ball from 100 feet high, right away, the golf ball needs to seek its equilibrium. It's definitely heavier than the air around it, and so it begins to fall. And as it falls, it's gaining speed because it's obviously going faster than it was just a second ago. I don't think that you need to call that an acceleration to me. So I could be wrong. And again, we can have other people give presentations on this if they would like and try to convince me otherwise. I guess sometimes I consider myself rational simply because I like to hear both ends of the story. I like to hear both people's opinions. I like to hear if there's 10 different opinions. I want to hear them all, and from it pull the one that makes the most sense to me. And I think sometimes we might get trapped in this idea of force equals mass times acceleration and say, so if there's a force, then there has to be mass times acceleration. Who says that just because somebody wrote F equals ma that we have to have those? So that's kind of my opinion on it.
But going back to the question, why do things fall down? I think if you put it in the context of that little cherry tomato that's sat in between the layers, that tomato's not going down, is it? It's sat in a state of suspension. It's neutrally buoyant. It isn't moving. So it doesn't go down. It'll only go down if the medium it's in can't sustain the mass of the thing in question. So obviously humans go down. But if the human's in water, that human floats. Well, might drown. I know they can drown, but most of the time humans float. So it's not true to say that why do things go, for me, it's like asking the question, why do things go down, is the same as saying, well, why does temperature go down to zero and not go up to as hot as what it does? That's just the scale that it's been designed around. That is the way it is. But when someone says, well, things like, why don't things go sideways? Try filling a bucket up with vertical strips of water and then let me know how that goes, because you can see that it does fill up sideways. So it's just raising these points of awareness so that people kind of get their head around it. Things do fill up sideways when they're contained, and we are in some kind of containment. That's why smoke does go sideways. So the reason why things go down is the same reason why temperatures go up and down. It's the same reason why pressures go up and down. Don't know why, they just do. It's just the way it is. But it's relative to the medium that it's in. So when people say things like, so density and buoyancy explains everything, forget density and buoyancy. It's relative density, right? Because buoyancy's got little g in it, for starters. And the minute you put buoyancy and little g in it, then you basically lose your own argument because it's got little g in the maths. So it's relative to the medium that you're in. If you're too heavy for the medium that you're in because you've got more mass than the medium that you're in as, you're going to displace it because it can't sustain your equilibrium. You're not in equilibrium. So for me, it's really easy. I understand it, but I like picking up the idea of this up and down, because don't forget the current science by Einstein. According to Einstein, down is the direction in which time travels more slow. In that context, it can't be up and down if you're going to apply the current science, because time dilation is not a direction, it's time. So it can't be up and down if you're going to apply the current science. So it's easier to describe things in your head as less dense or more dense. And you can demonstrate it with the Cartesian diver. And I don't know anybody that would be able to disagree with the Cartesian diver. If you squeeze the bottle, the Cartesian diver drops. You let go of it, it goes back up again. And you're controlling the density of that diver. So it's like, I don't know how much more explanation you need. If that bit doesn't go in to demonstrate that it is the relative density that's causing the movement, then I don't think we'll ever get it. But that's okay. We don't need to get this. We don't need to understand this. It doesn't matter whether I'm right, wrong, or otherwise. What matters is they make the claim. They've got to demonstrate it.
Right.
So all we're doing at this point is having it like a conversation within a conversation. We don't need to have the conversation with them over gravity. Just say to them, prove it. And they can't.
And that's the
Whatever
thing, is that
they can't prove it.
No, and I think gravity is needed so desperately because it's needed in some way, in some form or another, in order to allow the Earth to be a sphere. And so for those of us who don't agree with that premise, then I think it's incumbent on us to demand that the very idea of gravity is proven. And it's never been proven. When you look at what Epicurus may have thought, then you go on to what Newton thought, and then you get superseded by what Einstein thought, and Einstein just comes along and applies some mathematical formulas and little g and applies the curvature of space-time. What they're all desperately trying to do is make sure that we can all exist on the outside edges of a sphere, and it's flying around in space. And you've got Newton, like we posted the quote earlier, that simply says flat out that he doesn't believe that gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum. So think of everything that we've been told about the heliocentric model. That's the whole premise. The whole premise is exactly that there's the sun, that there's the earth and the moon, and that everything is acting on each other because of an inherent force that resides inside of that. And so what Newton flat out says is that that's ridiculous. That by and through which their action may be conveyed from one to another is, to me, so great an absurdity. Now, we can realize now that they've ascribed that to him and that they've pushed that on him. But he clearly said here, and this is after the Principia came out, that he said, don't ascribe that to me. I don't want anything to do with that. Why? Because it's crazy talk. When you're talking about a force, especially when you're talking about a force in the vacuum, where there is nothing to draw those things together. He called it an absurdity. So to me, I think when we can just talk about relative density and everything kind of pans out, people can say, well, what about a big ball that is sitting on a table? Why does it have weight? Well, it has weight because only the table is holding it up from it going where it wants to go because of its equilibrium. It's out of disequilibrium. It's weighs a lot more than the air around it. Now, as soon as that hits some water, I believe the proper poundage on a bowling ball at 12 pounds is when that ball will float in water. But if you make it a 16-pound bowling ball, well, then all of a sudden that 16-pound bowling ball is more dense than the area around it, and it will sink. And if that bowling ball weighs 8 pounds, well, then it's going to float in the water, and it's all down to relative density. So to me, to try and ascribe a force or say, well, why do things go down? I don't think that's necessary until somebody gives me a reason why that has to be so. I don't see it. I just see it as a Band-Aid for this idea of gravity. And gravity is wrong. Even if you ask a cosmologist today or an astrophysicist, they'll tell you that gravity doesn't work out in the outer stretches of the universe. But no matter what, and if you look at things that Feynman has said or other physicists have said, Lawrence Krauss has said, they've all said if something doesn't match experiment, then you need to get rid of it. If these theories don't match observations, then they need to be discarded. The problem is you can't discard the one thing that makes the Earth a ball. And really, when you just go back and look at how the Earth began, are we to believe that there was a tiny speck of dust and then things started being attracted to that tiny speck? If that were true, then I'd be able to take a grain of sand next to a mountain and it would be sucked off to the side of that mountain. That doesn't happen. Why? Because we're only dealing with relative density, and the sand that I hold up only is dealing with the air that it's surrounded by. Simple.
I just want to address 2 comments in chat. Rune Thorsten says, the direction is not explained. It is. The vector comes from the 2 mediums. If you've got 2 mediums next to each other, one's got a value of 5 and the other one's got a value of 6. That is your vector. So if you put in an extra liquid in between them of an unknown density, or even of an unknown density, and you let it find its own its position will be found relative to those 2 liquids that are already there. So that is the direction. The vector comes from the 2 mediums.
Well, there has to be a direction. There has to be one direction, no matter what. So just think of that there cannot be no direction because you've got 2 items that can't exist together. You can't have a bowling ball sitting in air by each other and it be in equilibrium. So automatically, things have to go in one direction. So you might say, well, why isn't that sideways? Well, if it was sideways, then the Earth and all the mass of the Earth would be sideways, because it would not be in equilibrium. It would have to go in that same direction. And so would our feet. Our feet would be on the ground sideways. And then what would happen? Everyone would say, well, that's down. And then people would say, well, why don't things go the other direction? So you have to understand they have to go somewhere. They have to go in one direction. So that direction we call down. So you might say, well, there's a preferred direction of down. Well, it could be in any direction. It has to go somewhere. And people get very caught up on that. I don't see an issue with it. So again, I can understand where people have, and you have to remember, it's just like the sphere Earth. As hard as it was to discard that because we were taught it from such a young age, gravity has gotten to the point where somebody thinks they can hold a pencil up and drop it and say that's proof of gravity. No, it's proof that the pencil that you just held up is far more dense than the air around it, and it has to go somewhere. It has to get back to equilibrium. The problem is it falls until it hits the ground, at which point it has nowhere else to go. And then if you wanted to figure out what its difference in its relative density is, then you would put that pencil on a scale and you would get a readout of exactly how much more dense it is than the air around it.
The Marilyn Spirit Level said, relative density does cause the movement, but it doesn't define down. No, down, if you're going to apply the science, down's defined by Einstein as the direction in which time travels more slow. And obviously that doesn't apply. Whatever that means, it's not relevant in this application. But the direction of down is more dense. It's less dense going up. So even though everyone wants to describe it as up and down, really it's more dense, less dense, and it's relative to the medium that you're in at the time. So everyone forgets that we're in the medium of air. That's got a value to it. That's where the vector comes from, the medium that we're in. So everything is relative to our medium, and it's relative to its mass. Whatever mass it's got is relative to the medium it sits in. In the same way that, like swimming pool, you can't put a weight on a set of scales at the bottom of the pool, but you can do at the side. It's because the medium changes. So remember, this up and down thing, it's descriptive. It's not direction. The vector is caused by the medium that we're in, and we are in a medium. So that's where the vector comes from.
Yep, I totally agree. So any final words or else, and again, if people have a different opinion of this, like I said, email me, Jeranism@yahoo, put presentation in the subject of the email, and then tell me that you want to discuss the opposite opinion in this matter, and I would love to hear you convince me that there needs to be a down. But so far, everything that I've heard is just people repeating the same thing. Oh, it doesn't define the direction. It absolutely does. And again, it has to have a direction. So, meaning no matter what, it has to go in one direction or whatever. And whatever direction that is would be where we stand, would be where the Earth is. So there's no way it can be in another direction, or else that would become down. So somebody said, well, why doesn't it go up? Well, because if things went up, then so would the Earth that we stand on, and so would our feet, and then that would become down. We'd be upside down, but we'd be down.
Things do go up, don't they?
Sure, yeah, that's what I mean. It's relative density. If you pulled that cherry tomato down in that density tower, the cherry tomato will rise. It will go up.
So Bob asks, why is down the most dense if it's all relative then? That's the same as asking, why is cold freezing if it's all relative? Because temperature is relative, right? You've got a whole range of temperatures, hot, cold, somewhere in the middle. Asking why is down the most dense if it's all relative is the same as asking, why is cold frozen? It's just the way it is. It's the way it's been designed. It is exactly the same concept as pressure. Why is vacuum no pressure and loads of pressure? Pressure, it's just the way it is. There's no difference to density, and why is down most dense if it's all relative. It's the same for temperatures and pressures.
Well, I mean, to me, there's grass, there's rocks, there's mud, there's water. All those things are more dense than air, so they have to settle somewhere. And that's the same place our feet settle, and it's the same place that a golf ball will settle, and that becomes down. So if somebody says, well, why isn't it sideways? Well, because if it was sideways, then everything would displace sideways, and that would become down. So no matter what, there has to be a down, and to ask why is it that direction is kind of ridiculous to me. It's circular reasoning. Well, no matter where it was, we'd be asking the same question. So we as humans need to recognize that it doesn't mean there's a force in that direction. It's relative density, and no matter which direction it went, we would call that down. Our feet would be stuck in that place because we'd still be more dense than the air around us. So whatever direction it would be, it would still be the same. Meaning it doesn't have to be down. It could be sideways, but then that would adjust the entire world to the point where we'd be standing in that direction and calling that down. So to say it's a preferred direction is circular reasoning.
Yeah, but don't forget that we do smoke does rise and then level off. So we do have sideways movement.
Sure, but that would happen no matter where down was, is what I'm saying.
Yeah, it would.
So anyway, if and I'm sure check out Globebusters this Sunday. I'll talk a little bit more about this and get Ira's opinion. I don't think Bob will be there. He's got the Force the Line level experiment for FE Core going on this weekend. So check out Doe for sure. Globebusters will be on Sunday. I'm sure this will be discussed. And if anybody wants to give a presentation, all I ask is that we keep it about an hour so that people can retain the information, and we'll read the comments and check it out and see what people think. And I know this is not, people are not going to be on the side of Riley and I much here in this case, and I think it has a lot to do with the fact that we were all taught that things must go down, that gravity pulls things to the ground. I just haven't been convinced of it yet, but here's the great thing about being me. I'm open to anything, meaning I could change my mind in a second if it's simply somebody gives me the evidence that weighs me in that direction. It's the same thing with the globe. As soon as the evidence is overwhelming on that side of the argument, then I will switch my opinion. Right now, I'm staying with where the evidence shows me, and the Earth is obviously and observably flat. From a observation standpoint, everything I see tells me that it's flat, and certainly when you start looking at what these guys have told us about the sphere Earth spinning in the outer space vacuum, none of that stuff makes any sense to me. It doesn't jive, and so I've discarded it. And as far as gravity being a force, as far as a force equals ma, no, I don't need it. So let's read the super chats. I forgot to do that real quick before we go. Let's see here. We've got Josh Horn. Thank you very much for the $2. We got Leanne Guy, my #1 mailer. Thank you so much. $20. Appreciate that. Much love from Tennessee. We got Renee. Calucia said, exit the Matrix, May 25th, 26th, Las Vegas. Let's unite. Yeah, I heard there's I guess there's going to be a debate between Mick West and Nathan Thompson, if I'm not mistaken. I believe that's at the Exit the Matrix event, and you can go to madmikehughes.com to get tickets to that, and I think you can also stream it live. Thank you very much, Artem Brayson, for the 99 cents, and Tasia Brayson. Don't know if there's any relation there. $1.99. Thank you very much. Einstein's pathetic theories are debunked by Tesla. Artem Bryson again with the 99 cents. Jerry Hoffman, so brilliant, for $2. Thank you very much. And flatter channels must be shared to all children for $2 from Renee Calosia. So thank you guys so much for the super chats. As always, I do appreciate it. If you want to support me in any other way, you can go to paypal.me/Jaron. I also have a Patreon. One of the things that has come up recently, and I guess I'll mention this real quick, you'll hear me talk about it more, but I do have the option now for channel memberships on my channel, and I'm not going to be turning them on, mostly because I can't figure out a way to do that and also have my Patreon. And the Patreon's kind of a saving grace. If my channel ever went away, I'd still have my patrons. I'd still be able to post videos there. I'd still be able to do either live streams in another fashion, but still be able to cater to those people. If I started pulling people off Patreon and said, hey, instead of spending $5 there, come over and do a channel membership, it's just not going to work. How can I have a channel membership only chat and not allow my patrons to go over there? So even though that's available to me, I'm not going to be doing it. So if you want to support this, I would really appreciate it if you go to patreon.com/Jeranism. Or if you have Venmo, you can send that to @Jeranism. The other methods have been taken away. I no longer have an Amazon affiliate account. I was removed from their platform. And there's been some other ones through the past that I can no longer do as well. So these are pretty much the only ways. Anthony, tell people where they can find you one more time, and then also if there's a way to support.
Sleeping Warrior. Just type in Sleeping Warrior on YouTube. You'll find me really easy.
It's that easy? Wow.
Yeah.
All right. And so go ahead.
I don't have a monetized channel, so there's no support that side of things. Just one thing though, Karen B just said in chat, if you ask 1,000 people what direction down would be, what do you think is going to happen? Ask that same question to a fish and see what happens. If they could speak the same language, obviously, but a fish doesn't understand up and down.
Yeah, well, I think the answer to that question is they would tell you it's down. I don't know what that tells us. Again, I can't wait to see some of the comments here. I'm hoping some people see our side, but again, it doesn't bother me anymore. If people don't see things the way that I do, that doesn't sway my opinion anymore. If I cared about what people thought about my opinions, believe me, I'd be a sphere earther. I'd be talking about living on Mars and talking about the remote control car there and how it makes a lot of sense that we haven't been back to the moon in 50 years. And it's another thing to look forward to, guys. I did do a 2-hour show with Mel Fabregas from Veritas Radio yesterday. Awesome talk. We did a whole 2 hours on moon landing stuff. I do not think it's going to be out for about another month, though, so just look out for it. And when it does come out, I'll put the first hour of it on my channel. But the second half, I believe you got to be a member with Veritas Radio. But he's one of the best interviewers that I've ever heard. He's awesome. I love listening to his show. So look forward to that. And just a thank you to all my patrons, because like I said, I wouldn't have this channel. I wouldn't be able to do nearly the amount of stuff I do without them, and it allows me to do something that I love, and their help funding my existence. So I really do appreciate it. Can't say thank you enough. And if you want to send me snail mail, you can do that too at Jeranism, P.O. Box 3044, Merced, California 95344. So also go over and right now support our at least, let's see here. I was going to bring it up, and now my thing doesn't work. Oh, there we go. If you want to head over to, nope, still not working. Interesting. I usually have a browser button that works, but it's not working today. What if I do that? Oh, there it works. Okay, guess we'll do it this way. Yeah, go over to Sleeping Warrior's channel. He's got how many subscribers right now? 2,869. So hopefully after this live stream, and it's up for a little while, let's get him above 3,000 subscribers. You think we can do that? I think so. So head over to Sleeping Warrior. He's got a couple videos he's done recently that kind of centered around this talk today. How the independent variable literally destroys the ball, applying the scientific method. Does a lot about relative density. And what did you do your most recent one? I haven't seen this one. Blue Marble Science is Dishonest. I haven't seen that one yet.
Oh, let me give you a quick plug for that one.
Okay.
I did. I obviously had a video about relative density, and what I did towards the end, I made my points, and one of them was about inferring causation in scientific method. You can't do it. He snipped that bit out and didn't address it. And then at the end, I did a deliberate, intentional pregnant pause, whilst I then contrasted and wrapped up my video, like all the points that I'd made earlier. I did a pregnant pause, then concluded, and he snipped that bit out as well. So the whole substance, the main substance of the video, he snipped out. and he addressed the rest of it that he left in and made me look silly, which is not that difficult to do if you snip out the main part of it. But it's like, if you're going to do a criticism, shout outs to the people that are subbing now, because I can hear you coming through. If you're going to do a constructive criticism or whatever you want to call it, at least deal with the point that the video's making. Don't do a video and then snip out the bits and pieces that you don't want to address, because they kill your argument. So basically, go over to Blue Marble Guy's video and basically tell him that you've snipped out loads, because you should be dealing with the points that you've snipped out, not snipping them out so that your own subs don't get to know that they exist. That's like the most dishonest thing you could ever do. Shout outs to the subs coming in. Woo!
All right, good. Yeah, thank you guys for subscribing. And there is a link in the description. It's the very first link that you see. And then I think I linked 2 of his videos. And again, if you're interested in doing a presentation, it doesn't matter if you have no subs. That doesn't bother me. It's not about that. It's about good information getting out there and allowing people to watch and learn and then decide for themselves. And that's the point of this show and this channel. So contact me, Jeranism at Yahoo. I'll be looking out for anything with presentation in the subject. And let's get you on and give you an hour to speak your piece, and we'll go from there. So appreciate everybody. Again, I remind you to do your own research, because when you do, you'll never again believe what you've been taught. Till next time, this has been Jeranism and Sleeping Warrior. Peace.
Yo.